Okay, so let's discuss this next point here. So switches. Now, how switches can work in a series or parallel circuit is actually very different from each other. So this will be better explained when we look at an example. Okay, so let's look at a series circuit. I'll just use a simple one here. Okay, so 2 light bulbs and a switch. Okay, so because the electrons have only one pathway, if you remember when we first learned about switches, we know that when a switch is open, so let's say we have something like this, an open switch, these electrons do not flow. So how series circuits work is basically the switch controls the entire circuit. So when this switch is open, the entire circuit is basically off, right? These bulbs are not going. But if we were to close that switch, now all the electrons would be flowing and the light bulbs would be on. So there's not really a ton of control. If we can control the electrons being on, flowing or not flowing, right? So the light bulbs would be on or off, but I couldn't control the individual light bulbs. So it's either all on or all off. Now, when you have a parallel circuit, though, let's see here I have, let's say I have, I'll draw it a little bit differently. So let's say I had a bulb here, and then another bulb here. Okay, let me just clean that up. Okay, so let's say I had a parallel circuit. Now, where I put my switch is actually important. So meaning I can put a switch on the line that has only one light bulb. So this switch can only control the electrons on this pathway. Same thing with this light bulb. So remember, it has to be after that fork in the road. So here's that fork in the road section. If I put a switch on the line extending outwards, that means that this switch can control this line. Okay. Now, if I were to put a switch here, though, this would still control the whole thing because it's on the main pathway. So in order for a parallel circuit to be the most advantageous or the most beneficial, would be to have this switch on the actual line with the load. So this makes it possible to open or close one of these lines. So if I want this light bulb to turn on and I want this light bulb to turn off, I can do that. It's not all on or all off. And actually, this is how most things are connected. So for example, if you turn a light switch on in your house, the whole house doesn't turn on. Imagine you turn on a light bulb and like your stove goes on, your oven's on, same thing, a microwave's on, all the lights in your house turn on, your TVs all turn on, the computer's on. Like, it would be a little bit ridiculous to have one switch controlling the whole house, right? So most places, pretty much everything is connected in parallel, because when you turn on your TV, you want only the TV to turn on. You don't want the whole house to turn on, right? So that's the benefit of doing a parallel circuit here. Okay, so just comparing pictures, right? So series, right? You have one pathway, and here is what it would look like, right? So you have 2 loads, and here this switch is open, so the light bulbs are off. But you have only one possible pathway. So the electrons are not flowing now, but I just want to show you. So your parallel circuit, though, if you notice, here's the fork in the road. So the electrons have more than one path to travel on. And you'll see that, right, when you're looking at it, and you see that branch off. So that's how you know you're looking at a parallel circuit. So what are the uses for series circuits? Not very much, to be honest. The most common use that you maybe are aware of is Christmas lights. So sometimes, and actually the newer Christmas lights don't even do that. The newer ones are also parallel. But let's say you had a string of lights. All right, so here are my Christmas light bulbs. Sometimes when one light bulb burns out, the whole thing burns out. And if you have maybe some older lights that you put on your tree or outside your house at Christmas time, you'll sometimes see like a whole string kind of blows out. But it's actually not because the entire string is done. It's usually because only one light bulb is burnt out. So the whole thing, it's like all on or all off. So this is actually really bad because, well, it's going to take some time to figure out, well, which one, especially if you have a long string of lights, which one is actually the one that's burnt out or not. So in terms of parallel circuits, of course, the example is this is used to wire everything. Basically, everything else other than old Christmas lights is used in this way. And of course, there are circuit breakers and fuses that are safety mechanisms to make sure that there is not an overloaded circuit. But that's the case with, this can be really used in any situation, right? It's more of a safety concern for electrical fires. Okay, so that's series and parallel circuits. So it's very important that you are able to look at voltage and current and know when you're looking at something how the relationship is between those two.